All right, so welcome everyone to this first RobotPerf meeting. We're going to be conducting these meetings weekly and hopefully packing lots of people. Since it's the first meeting, I think it's worth as well maybe making a short round of intros, though many of us know each other from the Hardware Acceleration Working Group. I think it does make sense to just share a bit of ourselves and what do we aim to contribute to the working group. Just as an FYI, there's not too much preparation for this first meeting. What I've done essentially is put together a small agenda, which will focus on us getting to know each other, touching on the basis of the project, the resources available. Then I'm hoping maybe PG and Jason can comment a bit also on the strategic aspects and how we want to drive this forward based on past discussions. And then what I've done is, if we have time in this first half an hour, I have prepared a short one-on-one walkthrough on how to create a new benchmark. So there's one benchmark in the report right now, but I just thought that it might be worth doing a deep dive into the source code on how easy it is actually to create a new benchmark. And I have everything prepared in principle to walk you through it. So let's see if that makes sense, if we have time for it, and then it will be recorded for others to also benefit from this. So we can always refer new people to this first recording, and that way they can get up to speed faster. So with that, let me once again paste in the chat for those of you joining just right now. Here is the link of the minutes. Officially, the RobotPerf project is a sub-project of the ROS2 Hardware Acceleration Working Group. We're doing this for many reasons. The first being we're trying to leverage much of the traction we have generated in hardware acceleration also to this very connected and crucial topic for also high-performance systems, which is benchmarking. So we'll be conducting this in the same room, in the same resources. So with those minutes shared, one week, guys, maybe just do a round of intros. I think there's some folks in here who have not participated in the firm and might have some contributions to send in. In a nutshell, and since I'm asking for it, I'll get started. My name is Victor. Hi, everyone. So I'm a systems architect, roboticist for more than a decade now, very involved in the ROS community and very interested in benchmarking in a reproducible manner, in a real-time safe manner, in a somewhat consistent way, robotic systems. That's why, together with some of you, started this RobotPerf project, and I'm very excited to be contributing to it. I'll be supporting both on the admin side as well as on the technical side. And yeah, hoping that all of you guys in here can at least contribute with one benchmark. That will be fantastic. Who wants to go next? Please just go ahead.
Cool. Thanks, Victor. I'll go next. Hey guys, I'm Jason. I'm a first-year graduate student here at Harvard under the mentorship of Professor Janapa Reddy. And I will also, I'll start with my background. My background is in, I'm doing reinforcement learning research and some robotics research, and working on several different types of benchmarks. So I'm really excited to work specifically on ROS benchmarking. I will be also working as like an admin and a technical contributor to this project. Hopefully getting a few benchmarks in pretty soon. So yeah, excited to work with all of you.
Thank you. I'll go next. So my name is Pratik Nagas. Earlier, I have like around 6 years of experience in robotics, especially working with ROS and ROS2. And I had a company called Technoyantra, service-based robotics company called Technoyantra in Pune, and we got acquired by Victor last year. So now I'm part of Acceleration Robotics, leading the expansion in India, along with Gaurav, who isn't there today. He should be in the next meetings as well. And yeah, I'm happy to help in any way needed. And from benchmarking perspective, we specialize in navigation here. We'll be concentrating on navigation quite a bit. So hopefully some benchmark on the navigation side, we should be able to contribute.
Okay, maybe I can go next. Hi, my name is Haiza. any pronouns. So my background is control systems and robotics, and I've been accompanying the hardware acceleration group for a while now, but now I'm like excited to try to contribute to it. So that's why I'm interested in this RobotPerf subproject.
Yeah, I can go next. Hi everyone, I'm Yushen. I'm a fourth year PhD student with VJ. And a little bit about my background, I've been working on autonomous vehicle, drones, and now robot arms. So mainly to enhance the resiliency and accelerating such robotic applications. So I'm excited to contribute, and then we'll be helping the technical side with the hardware team.
Yeah, and hi everyone, I'm Matthew, and I just finished my PhD here at Harvard too in intelligent chemical sensing systems. And now I'm doing a postdoc with VJ, and we're working on, this is one of the projects I'm working on, helping out Jason and Yushen.
Okay, one.
Yes, I'll go next.
Maybe I can go next. Hello everyone, my name is Zishan. I'm a third year PhD at Georgia Tech, and I received my master from Wages team at Harvard, and also still work closely with them. And my background is in the robotics, autonomous machines, computer architecture, and also the kind of chip design. So I'm very interested in the benchmarking. It's the workload. I think it's very promising, and I hope to can contribute something here. Thanks.
Hi, I'm Kunal. I have been working on mostly the perception side of robotics, and I was also maintainer of point cloud library. So, hardware acceleration is really crucial for getting the max performance. So I'm just lurking around and looking at what direction to take the project in.
Cool. Thank you, Kunal. Good to have you.
Awesome. I'll go, folks. Hi, I'm BJ. I'm a professor at Harvard, as many of my students and postdocs are here. My interest is primarily in architecture and systems, and I tend to do architecture and systems across a variety of different workloads, robotics being one of them, but there's extended reality, aspects of neuromorphic computing, and so forth. So the lab does a lot of different things. One of my interests around benchmarks is that I love building benchmarks, especially from a community sort of standpoint. Like getting the industry together and so forth, and that's how I kind of met Victor and so forth. So I built benchmarks of machine learning, scientific applications. Robotics has always been sort of on that horizon, but never quite seemed like it was right. And I'm pretty convinced personally that I think the timing is right to do something big for the industry right now. I think whatever we do, at least the beacon in my head is this is something that can actually set industry trends, not just be like, oh, here's something for the Ross group, So that's sort of like what I have in my head about the project, and I'm pretty sure we can do that. So.
We will, certainly. Thank you, Vijay.
I can go next. Sorry if it's a little bit noisy. But hi everyone, I'm Michelle. I'm a third year undergrad at Harvard studying CS and astrophysics. I've mainly only done research in my astrophysics background, so this is like my first research project having robotics, but it's something that I've always been very interested in. So I'm very excited to be a part of this team and to be working in this team.
Thank you.
Hello, my name is Jorge. I'm an artificial intelligence engineer here in a company in Pamplona doing facial recognition. I'm doing this in my free time. I'm passionate about FPGAs and robotics. I won the Adaptive Computing Challenge some time ago. I don't have a lot of time. I will try to do my best. So that's all for me. Thanks.
Jorge as well. Thank you. Awesome. All right. So just mindful of the time, we've almost consumed half of it. This is a team that's going to set the industry standard. It's going to grow over time, but you guys are the trend makers for now. So looking at the minutes, and again, anyone else, feel free to add yourself or to it. Just real quick, you've got the resources of the working group over there and of the RobotPerf project right in here. Just two remarks that are worth checking. First is the specification of the benchmarks that you've got linked in there. Of course, the website and the resources that you can see the source code. And also, please, the standards. One of the key crucial aspects of us and the work that we'll be doing in here, as BJ highlighted, is trying to go beyond the ROS community. And for that, we should probably establish standards that, while aligning with the interest that we have short term, which is providing this for the biggest ecosystem out there in robotics, which is the ROS community, we should keep an eye about this standardization action. So just a friendly reminder for everyone that these norms that we are building, let me stress that, actually are great resources to get started and learn about it. So yeah, I just wanted to open up for the discussion. If there's no topic to be discussed, I can give everyone a quick run on the source code structure and how to run a first benchmark. But I'll just leave that to everyone. So anything worth discussing, folks, in this first meeting? Anything anyone would like to raise as we are starting with the project? Maybe one aspect. Go ahead, please.
One thing I was just kind of thinking is like, before you dive into the depth, right? Maybe it'll just be good to kind of walk through the README and kind of like specifically focus on the different categories that we want to build the benchmarks and so forth. So I think that because immediately I think people will be like, oh yeah, I can do something in that space, right? Because we already have people in control and navigation and so forth.
Totally. Noted. Let's do it. Yeah. Indeed. So let's dive into it. So here's the minutes. Hopefully you guys can see it, and I'm going to get into just showing you the flow. So this is the website, and here we access the resources in GitHub. So there's an organization, everything is disclosed, open source, and we'd like to keep up with that mindset. There is a general README that is hosted at the organization level, but really what's showing is actually one of the repos, particularly the benchmarks one. All right. And as BJ was highlighting, we have here a formal definition of what we are aiming for, mission as well as vision of the project, which I will not touch on a lot today just for the sake of timing. But what's important is to make sure that we stress that we are trying to somehow pack benchmarks into these 5 initial categories. And I say initial because this will grow over time. And we're already getting some requests actually from industry players to add new categories. What I'm doing is pushing back and saying, contribute a benchmark, and then we'll fit it into a new category. So that's going to be the attitude so far, just to try to focus ourselves on it. But just as an FYI, there will be additional categories. And examples will include very possibly infrastructure, such as the message passing infrastructure that ROS2 has itself. This is kind of like meta aspects to benchmark when it comes to robotics, especially, again, the infrastructure that allows different robotic components to communicate with each other. This does not necessarily fall into any of these categories, but it's something that applies to all of them. Other things include other layers, such as the operating system, such as the networking stack, such as the data link layer. All of these things are also being requested. So eventually, again, as we get more and more industry participation, we'll enlarge this category. Comments, thoughts? I presume everyone's fine with this initially. All right. So
I think, Victor, I think it would be helpful to quickly go over the terminology that we're using, because I think it can be really helpful to understand what we mean when we say benchmark. So what Victor and I have discussed earlier is what you see here on the screen. For example, A1 in the perception table. So that would be considered as one benchmark. So we would choose a specific node or a specific function within a ROS package, and we will evaluate it on a set of metrics that are listed in one of these specifications Victor has made called REP 2014. So our vision here is that across each one of these areas of the robotics pipeline, we would choose several benchmarks, so several different applications inside, like perception, localization, control, and so on. And then we will also provide data sets to feed into these nodes, and then we will evaluate how well they do on those data sets, or ROS bags, which is like the name of the repo, on the set specifications that Victor has made. And then once these benchmarks are created, then members of the community can like easily run these benchmarks on different types of hardware, and they can evaluate how well they do, how well they compare in performance to like the reference implementation, whatever hardware we've evaluated this benchmark on. That's like a little bit of a broad overview that I think is like important to kind of discuss. So I hope that like clears a little bit of what we're aiming to do.
That's super useful. Yeah, and thank you. And please, guys, just interrupt me because I'm so contaminated that I'm assuming so many things that possibly here we just need lots of questions and people questioning things, and indeed all of that is described in the corresponding package. So essentially, this repository is a package of packages, a meta package. Everything is ROS based. So in a nutshell, what you should expect is just a hierarchy of directories that organize each one of the benchmarks, each mapping one-to-one with a ROS package. And so there is the usual structure of a ROS package plus a new file called benchmark.yaml that meets the specification, the benchmark specification that's defined in here. And that file just contains metadata to essentially help out automate the process of adding new data from new hardware devices or from the same hardware devices, just in different instances of time, and then just automating things from a continuous integration purpose. So that's pretty much the objective, to try to achieve as much automation as possible. And that's what we're currently working on. What I can do for you guys, if you want to, also for the sake of advancing in this first meeting, is, so I did prepare prior to this meeting a new contribution, which is a second super silly benchmark, so that you can see somehow what the structure should look like. And then I'm going to try to do this in 5 minutes, and then we can spend about 5 to 10 minutes if people has a bit of extra time to discuss things and launch questions, as well as taking maybe some action items. Does this make sense, folks, or should we instead do something else? Yeah, all right. So then let me get this ready. So what I'll start is with a demonstrator, if that's okay. Let me fetch this real quick. And okay, let's see. There we go. Okay, so here is one of my development machines. All right, and what we're going to do initially is just load the computational graph. It's pretty empty, nothing's happening. That's what's expected. And now we're going to publish images into the default camera image raw topic. And if we update the graph, then we can see this representation, which depicts in a nutshell how we have a super simple graph. Just, oops, okay, mouse issues. And again, there's this ROSBAG player, which is publishing in the corresponding topic. Nothing too fancy, nothing too surprising. And now what we're going to do is launch one of the benchmarks. And this is happening on a different screen, but just for the sake of clarity, here's how you would launch it. So nothing too fancy, general ROS2 launch stuff. We're just using one of the DDS implementations, which is known to be reproducible. The default one is unfortunately not recommended for benchmarking purposes, neither for performance purposes. But you can experience with that yourself and experiment with that yourselves. Nevertheless, as soon as we launch this computational graph, what happens right now is that suddenly we've come from a ROS-backed player that's publishing into the corresponding topic into now a graph that has been loaded. And as you can see in here, there's a first node that gets the data that comes from the ROS-backed player. This node publishes the data into an input topic. And right in here, we start putting the trace points to collect data and perform benchmarking in a systematic and reproducible manner. We use ROS2 tracing project to do so, which is already fully integrated into ROS2 and which provides many things, but amongst them capabilities to abstract away the complexity of leveraging low overhead and real-time capable tracers such as LTTNG. So in a nutshell, there's a series of trace points in here and at this topic level. Technically speaking, they happen in the node, but anyhow, just for the sake of the abstraction, information gets traced from the moment they go into the input topic, and then we collect the output outside of this bounding box, outside of the benchmark namespace. And so, of course, what we are benchmarking in this case is pretty well bounded. It's within the benchmark namespace you can see in there. And so we can push in there multiple nodes. We can put complete perception or navigation subgraph. And that's pretty much what we will be doing. Of course, each benchmark should be well-defined. And whatever happens within the bounding box, within the namespace of benchmark, is what should be what we will be reporting about. This super silly example, again, just benchmarks a single rectification operation. Actually, you can see in here how silly it is that we don't barely see the difference. We have the information being published in the first box, in the first window, sorry, in here. This is what comes from the ROS2 ROS-back file. The second one is what we get inside of the input topic, so what gets pumped into the benchmark itself, and then what we get out of it is depicted in here. So now, with this in mind, with this picture in mind, we can dive into the source code actually, and how does this map. And one thing I wanted to convey early on is that the benchmark repository itself actually has been created in a somewhat development-friendly and conscious manner. So actually, technically speaking, in case you're not familiar with depth spaces of VS Code, so typically you will develop locally, right? And so each one of us have our own operating system with our own version and libraries and dependencies and so on and so forth. And often in the case, reproducing things can become really cumbersome because, again, each one of us have our own setups. So what we, and what I would suggest we do is that instead of developing natively in VS Code, we use something called depth spaces, which allow us to develop inside a Docker container. And it's as easy as just simply entering the Docker container. The same window reopens within the Docker container, only that the dependencies and everything required is pre-installed and predefined by ourselves. And I'll show you just right now in a bit where these files are defined. What this means is that every single thing we do regarding benchmarking and regarding the benchmarks repository is going to be totally reproducible. So apparently it's taking a bit of time. Wanting the container, it appears. Not really sure why it's taking so long. This is the first ever. Oh. Okay, let me try to reopen it. So actually, I want to go in here and this is it. Okay. There we go. So again, this is locally. I'm just going to give it a try again, and if not, we'll do it locally. Nevertheless, this is as complex as it gets. I probably might need to just restart my Docker daemon. No, actually, here we are. Okay, so it was just a glitch, I guess. So now we're inside of the Docker container. So everything is exactly the same. You can benefit from your usual favorite VS Code depth environment. By the way, the same capabilities also in Sublime Text and in various versions of this. So in case you prefer not to use VS Code, that's totally okay. There are alternatives. The source code is in here. And all of this is abstracted away by a series of metadata files that have been prepared for you. In particular, there's a Docker file, which get together the environment that we want for the sake, again, of having something consistent. And then there's this file, which in a nutshell prepares the environment so that it gets mounted in the right volumes of the Docker container so that you can have this funny and nice ROS2-friendly and benchmark-friendly environment, at least for development purposes. Of course, the results you may get out of this should be taken with a grain of salt because this is only for development purposes. Then you need to run on target to get the actual data. Of course, this also gives you a CLI, which in our case, we're going to use to first resource /opt ROS humble. So as you can see, it directly gives us a CLI into the source code and the workspace. And the next thing we're going to do is call con build -- merge install. Okay. So this is how we build our workspace, and now we're building all of the benchmarks. It's just going to take a few seconds. And then after that, we would be able to have our workspace built. We could source it, and then we could launch whatever example we were. This is typically what you would be doing while developing, because of course you want to validate that whatever piece of source code you have produced can actually turn into an actual node that can be launched. So leaving that aside and taking a quick look at the code, let's look at this new example that I produced, this HAWG rectify. So from the bottom of it, as you can see, it has a typical structure. It has a package.xml and a CMake list of txt. In this case, it's a terribly simple ROS2 package. One that is depending on a previous benchmark. Nothing too fancy in here, just average package.xml. If you know ROS, this should come pretty easy for you. And in the case of the CMake list of txt, it's trivial because we are not defining any new node or component. We are actually just simply deploying the launch files into the workspace. There's also the corresponding benchmark.yaml file that we described before. And again, this is needed because we aim to auto-generate most of the data in the benchmark repository. So there should be a continuous integration system integrated, and whenever there's a pull request that gets accepted, that CI system should review everything, update the tables, update everything from the metadata. So we will be using this. And that's pretty much it, the structure of the metadata of the package. Now the real juice is just testing. So again, super simple, ROS2 package, just a launch file. And what this launch file is doing, actually, it's just launching a trace instance so that we collect the data. And again, this is going to produce an LTTNG trace that we can later post-process to collect the corresponding data and then generate plots or whatever we want to. This is going to be what we will be using then to draw conclusions about how good or bad this went. And the computational graph is defined in here, in this composable node container. Technically, what we are doing is defining the input node, the output node, and this comes from, again, the prior example, the prior benchmark that I defined as a first example. And then this is the novelty, or I should say the simplification. We're just defining a single node, and we are pretty much bounding this within the corresponding namespace, which is benchmark. And that's what you see mapped once again here in the computational graph. So that launch file translates to this computational graph. It is as simple or as complex as that. There's nothing else source code wise. Now, in terms of launching this, it actually isn't complicated at all. So let me just reproduce it for you. I'm just going to stop these few things. And if we update now the computational graph, we should see an empty situation right now. Again, there's nothing. But if we just take the action of launching the data, what happens from a computational graph perspective is that, again, now we have the ROS back playing, and of course, we start getting information. But only in this. The corresponding topics that correspond with the input of the benchmark or the output of it don't show anything because there's no actual computation happening. Now, the moment we do launch our benchmark, the rest of the graph deploys, and then boom, we just get the whole thing. And so, of course, as you can guess, that's not the only thing that happens. The corresponding data is being logged, and we can search for it typically in ROS tracing, and then the name of the benchmark, and this gets defined in the session name of the tracing file in here. So we should look for this. Oops. All right, let me see what happened in here. So I know what happened. What happened is that I didn't recompile, and that probably is just pushing things into this guy. Yeah, I'm pretty sure, because that's part of the stuff. So double check that real quick. Perception, HAWG. I check the launch file. Well, that's probably a glitch on my side, yeah. Well, probably something I need to review, but the data should be there. Typically, the data is in that folder that I just showed you. And let me just go again, ROS tracing. And typically, let's just get this one as one example I probably did before. And so in here, often the case, we just want to use tools to visualize the data. The most common one is to use double trace in here, and just lots of stuff. This one is also, let's just do, for example, let's do, I don't know if this one is good. Yeah, this one's good. So this is the data actually that gets logged. This is what we should expect out of a benchmark. Of course, this needs to be digested in a programmatic manner. Nobody should be looking at this manually, but this gives us plenty of information. If you see the time kind of like resolution, we get nanosecond level resolution, and we can actually change the clock. This is one of the beauties of ROS2 tracing and LTTNG. We can do benchmarks across machines while syncing clocks. Very powerful tooling, very, very powerful tooling. And if you want to see an example of how this can produce actual plots, then I encourage you to go into the first benchmark that has been produced. And over there, we did produce a series of plots showing, so there's in here, not only the tracing files, but also some files to do analysis. And these ones show how to digest that data and how to plot it. And if plots is what you're looking for, then check out preliminary results that we disclosed earlier, such as this ones. So that's in a nutshell. Apologies for this extra 5 minutes, but I thought it was worth just doing an end-to-end sort of like walkthrough. I'll find some time in the coming few days and wrap up this this HAWG example that I had in this branch and make sure that it's up to the expectations. But that's pretty much what's expected from this point on. And with this tutorial slash very quick walkthrough, you guys should have the tools and should have the structure, as well as, of course, the possibility to criticize, improve, and send improvements of the project, of the backend, of what we are aiming for. We will be meeting weekly, and we will be discussing benchmarks. So yeah, that's pretty much it from my side. Any comments, questions? Open it up for you guys.
One thing I mentioned for the students on the call, like you folks should all try and get together and kind of, you know, understand the code offline together and so forth. I think that might also just help build a shared mindset, because then you folks can ping pong off of each other. And
Yeah.
Zishan, just so you know, like, you know, Celine's obviously interested at Georgia Tech, and Haisun might also be interested. And if you can connect with some of the students, that would be good.
Sure, of course. Yeah.
Yep. Yeah, and folks, if you struggle, have issues or whatever, tickets are out there. Just raise a GitHub issue. That's why we have the project in such an open manner, and we'll try to all together tackle it. I went very fast, and I apologize for that. Some of you may need to learn some stuff. Some of you may know everything, and it's just gonna be just super easy and straightforward. But this is pretty much it. Contributions are super welcome. Improvements are super welcome. And as we discussed in the past, we'll be iterating on every single one of these weeks, hopefully discussing more hands-on results. Expectations from our side and from my side should be that the following weeks, I think we will wrap this first version of the tools, to start producing benchmarks faster. And we will also hook it with our continuous integration system to start throwing data, at least for preliminary benchmarks. So then at that point, for every single benchmark that we add, we will be literally just automatically producing data across the boards that we have in our build farm. We can easily add new boards if necessary, but with that, we'll have the 2 core components necessary, the main structure, and then the automation to start producing data. So yeah, not sure, BJ, Jason, did I leave anything aside?
No, that was great. Thanks so much for the walkthrough. That was very, very helpful. So very much appreciated. Yeah, so next week we can share with everyone like maybe a plan of what benchmark people would like to tackle. So that way we're not overlapping in our work. And so we can kind of like plan out what we aim to accomplish in the next upcoming few weeks. So I think that
I love that idea, and maybe an action on that would be, or 2 actions would be, how to structure that out so that it's also disclosed in a way that people out there is also aware of the direction we are going, and so that they can get motivated. And I'll bring a few ideas on that. And then 2, I heard a few times that Jason, you, and I think also BJ, you guys mentioned data sets versus raw specs. I actually like to generalize things, and I agree that we should keep an attitude that goes beyond just the ROS community. So just give it a thought. But if you guys believe that data set would be a better naming, then super happy to take an action there and change it. It's better changed right now before we automate everything, because then nightmares will come afterwards.
Sure. I've been using the word data set, but yeah. Either way.
Yeah, that ties in.
I've been using...
Sorry. Go ahead, Jason.
I've just been using them interchangeably, so I apologize. But yeah, I agree. We can like set a specific standard of what we want to call them.
Yeah, that ties in to what I was about to say, which is we should probably have like just some nomenclature so that we're all using the same terminology. You know, when someone says reference implementation, what do they mean? When someone says benchmark, what do they mean? Is the same as a task? Yeah, it's like a data set, for example, just so that we're not like talking past each other, but we're saying the same thing.
Yep.
I think for these kinds of things, I would simply say just one source of ground truth, right? So
yep, I like that.
The ref is right, like just issue the PR stuff that that Victor started off, right? So then we can find it, and then we just kind of build on what he started off. So
yeah, so feel free, Matthew, to maybe put together an additional document, a markdown file that can go at the root of the repository with nomenclature. I think that would be a great contribution, and I agree. And speaking of ground truths, maybe one last thing before we should be speaking about maybe the first research output that we will accomplish together, which will be a paper. So just to get the excitements up, BJ and I have been working on the site on essentially defining the building blocks and baselines of what could look like a first paper for RobotPerf. We're very excited about this, and we're hoping that you guys can contribute to that as well and be part of it. So more on this will come down the road. It's still a bit early on the work, but keep your excitement up, because this is going to be definitely, as BJ said, industry trend maker, or however you say it. All right, so anything else? Anyone else has comments, final thoughts? No? All right, then. Sorry for this 11 minutes extra. In terms of administration actions, we will be recording the meetings unless someone disagrees strongly. We will be making this available as well in the channel of the Hardware Acceleration Working Group, so that we keep them archived. But that's about it. Together with the minutes, that should be enough, I think, for keeping up with this for now. If anyone has resources and bandwidth to contribute further and do further work on the admin side, please reach out to me and let's coordinate. Very good, folks. Have a great day. Those of you in the US and those of you in India and Spain, go to bed. Take lots of care. Ciao, ciao, folks.
Bye-bye.
Bye-bye.
Ciao, ciao.
Bye bye.
Thank you.
Bye-bye.